I'd like to explain the basics of graphing rational functions. A rational function is the ratio of two polynomials. For example, 2x squared plus 3 divided by 9x cubed minus 4x plus 1. Both the numerator and the denominator are polynomials. We're going to break our discussion of rational functions into two basic families. Odd power functions, where the denominator is 1 and the numerator is 1 and the denominator is simply x to an odd exponent. And even-powered functions, where the numerator is 1 and the denominator is x to an even exponent. First, we'll explore odd power functions, and the most basic is 1 over x. So on the left, we have displayed a table of values for the function 1 over x, and I use Desmos to create the graph. So if we're trying to memorize the graph of 1 over x, we will observe that it is concave up in the first quadrant, concave down in the second quadrant, and it is restricted to the first and second quadrant. It has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. The other members of the family of odd power functions, x cubed and x to the fifth, have the same basic shape. They just increase in steepness as the power of x increases. So these are the family of odd-powered functions. What about the family of even-powered functions? The most basic is 1 over x squared, and I have displayed a table of values for 1 over x squared. We'll notice that it is restricted to the first and second quadrants, that it is concave up in both quadrants. X equals 0 is a vertical asymptote, and y equals 0 is a horizontal asymptote. And the other members of the even-powered functions have the same basic shape. They just increase in steepness as the exponent of x increases. Now let's explore translations of our power functions. What about this polynomial or rational function? It's in the 1 over x family. It has been displaced 1 unit to the left. So what do you think the equation is? It is 1 over x plus 1. Add the 1 first and then apply the 1 over x function. What about this? It's in the 1 over x squared family. It has been displaced 3 units down. It's in the 1 over x squared family. Subtract 3. This rational function is in the 1 over x family. It has been displaced 2 units to the right and 4 units up. 2 units to the right, subtract 2. 4 units up, add 4. This rational function is in the 1 over x squared family. It's displaced 3 units to the left and 2 units down. 3 units to the left, add 3. 2 units down, subtract 2. Reflections. Here we see the graph of 1 over x displayed in red. Its reflection minus 1 over x displayed in blue. And once again, we see that multiplying a function by a negative constant reflects it across the x-axis. For our even-powered function, 1 over x squared, again we see 1 over x squared in red minus 1 over x squared in blue. Once again, a reflection across the x-axis. This family is in the 1 over x, this graph is in the 1 over x squared family. It has been reflected across the horizontal, hence multiplying by a negative, and it has moved up 3 units. First we reflect across the horizontal, then we move the graph up 3 units. This graph is in the 1 over x family. It has been reflected across the x-axis and moved to the left 4 units. The reflection is accounted for by the negative sign and the moving to the left by adding 4. Vertical stretches. In red we have 1 over x, in blue we have 5 over x. Multiplying by a constant, a positive constant, is a stretching factor. The blue graph is a stretch of the 1 over x function. So how would we graph x plus 4 over x? We're going to back up. What we would do is we would break it up into 1 plus 4 over x. So 4 over x is displayed in red, and then we're going to add 1. How would we graph x squared minus 4 over x squared? We would rewrite it as dividing x squared into both terms, 1 minus 4 over x squared. So we would reflect the x squared graph, stretch it, and then add 1, move it up 1 unit. Reflect it, add 1, move it up 1 unit. And finally, what about graphing minus 1 over x squared plus 12x plus 36? This certainly does not look like a power function, but if we factor the denominator, we could think of this as in the family 1 over x squared, reflected, and moved to the left 6 units. 1 over x squared, reflected, moved to the left 6 units.